afternoon, class. Good afternoon, Mrs. Hui. Thank you. You can sit down. All right, then today we will look at how to solve simultaneous equations using matrices. There's a bit more information that we need to take down. Hopefully you've copied some of that information into your exercise books. Okay, I gave you one question in the last lesson. That was question 4. Form M equals P minus Q if P is matrix is 2, 4, 3, 6 and Q is 4, 3, 5, 2. Siegfried, give us the answer to that, please.
Column -2, -2, next column 1, -4.
1 and
-4.
-4. Did you all hear that? Okay, say that again. P minus Q is column
Column -2, -2 as and next column is 1, -1.
like that. -2, -2, 1, -1. Is that correct? Okay. All right, if you can follow, we'll go on to the next thing before we solve simultaneous equations. All right, the first thing there is transposition of matrices. When the rows of matrix are interchanged with its column, the matrix is said to be transposed. You with me? So if the original matrix is A, the transpose is denoted with an A to the power of T. So if matrix A is 3, 4, 5, 6, then A with the letter T at the top is 3, 5, 4, 6. It's not supposed to be to the power of T. Is that clear? Okay, next. If A, this is now on determinants. If matrix A is A, B, C, D, then its determinant is the absolute value for A. I'll just explain what that means. All right, this means we are going to do absolute value hopefully before the end of the year. All right, that means the absolute value of A, and it means that, let's say if A is 9, okay, like that, and if A is minus 9, like that. That means the absolute value means that you can never, the absolute value of this number is always a positive number 9. So the absolute value of 9 is the same as the absolute value of -9. It's just that it can never, what it means is that simply it can never be a negative number. That's what absolute value means. So if you evaluate and then you find the value for A and then you find that it's -9, then you just say the answer will be 9. Like that. It's always a positive number. It can never be negative. An absolute value of a negative number is always the positive number. Is that clear? Okay, so that's what it means there. Determinant is the absolute value of A, which means if you get a negative number, it will be the absolute value will be a positive number. We'll go through that in detail later on. So the absolute value of A is equal to AD minus BC. And like I said, if you get a negative number when you multiply A times D and then subtract the product of B and C, the answer will have to be a positive number. With a negative number, with a positive number, it's The same, just like here. Absolute value of that is 9. Absolute value of this is also 9. All right, next. The determinant of A, if A is equal to 5, 2, 3, 4, the absolute value of A will be 5, 2, 3, 4, which is, okay, 5 times 4 minus 2 times 3. Take note, 5 times 4 minus 2 times 3, you multiply diagonally. Okay, 5 times 4 minus 2 times 3. 5 times 4 is 20, and 2 times 3 is 6. So the answer is 14. If you had negative number somewhere, then it will automatically change to a positive number because you only have to accept positive values. Okay. Inverting a matrix, you know what an inverse is? It's the reciprocal of. If AB is equal to I, and I is the unit, it says I is the unit matrix. Remember what a unit matrix is? What's a unit matrix? Can someone tell us what a unit matrix is? Tama ako.
Unit matrix is a diagonal matrix in which the diagonal matrix, the diagonal elements equal 1.
I didn't hear anything. Repeat, please. A unit matrix is?
This is a diagonal matrix in which the diagonal elements equal to 1.
1, okay. Remember, a unit matrix is denoted with this and, okay, that's a unit matrix. So if I is the unit matrix and AB is equal to I, which means when you get the product of the matrix of A and the matrix of B, if you multiply and you end up with a unit matrix like the one I've just written on the board, okay, that means B is the inverse or the reciprocal of A. Is that clear? Okay, that means B is the inverse or the reciprocal of A. The inverse of A is usually written as A with a negative sign at the top. It doesn't, well, it's A to the power of negative 1. You all know that. And so A multiplied by the inverse of A, all right, A multiplied by the inverse of A, you know that the answer is usually 1. And it should give us the answer, which will be a unit matrix. So A multiplied by the reciprocal of A will give I, which is the unit matrix. So if A is equal to the matrix A, B, C, and D, then the inverse of A will be 1 over AD minus BC. Remember, AD minus BC is the, AB minus BC is the determinant of A, B, C, and D. Please make sure you're following. So 1 over AD minus BC, A to the power of negative 1 is equal to 1 over AD minus BC multiplied by D minus B and minus C A. Okay, D minus B and minus C A. Okay, so that's on inverting matrices. We'll look at 1 or 2 examples. Okay, a singular matrix is a matrix which does not have an inverse. The determinant of a singular matrix is 0. So the matrix 6, 9, 2, 3 is singular because its determinant is, if you multiply 6 by 3 minus 2 times 9, you will get 18 minus 18, which is 0. That means that that matrix is a singular matrix because it has no inverse. And that's how you find out whether the matrix is singular. Okay, you find its determinant, and if it is 0, then it is a singular matrix. Okay, equal matrices or equality of matrices. If two matrices are equal, then their corresponding elements are also equal. So if A is the matrix A, B, C, D, if A is equal to A, B, C, D, which is equal to E, F, G, and H, then A equals E, B equals F, C equals G, and D equals H. I think that's very clear. Okay, I have an example. I think I got it straight from your textbook. Let me just check which one. Okay, it's on page 3, I think. Sorry, page 290. If you can follow. Okay, A is given to be the matrix 4, 1. Should I say the column first or the row first? Row or column? Oh, it doesn't matter. Okay, 4, 1, 2, 3. We have to form A to the power of -1, which is the inverse of A. Okay, so the inverse of A is equal to 1 over the determinant multiplied by, okay, note 3. Should I go back to the information or is it all right? Okay, go back. I can tell. Okay. There. It comes from there. 1 over AD minus BC, okay, multiplied by, all right, note this is D, so it should be that. And then this should be minus B, and this is minus C, and this is A. Okay, you have to make sure you get this right. You have to take note and see if you can memorize it. It's important. Okay, so that's where that comes from. I multiply by, I get 4 times 3, and then 1 times 2. Okay, this is now D. This is minus what? B. This is minus C, and this is A. Okay, if we multiply, now 1 over 10 is this. 4 times 3 is 12. 12 minus 2 is 10. So I get 1 over 10, and I multiply by this. 1/10 multiplied by 3 is equal to 0.3. Okay, 1/10 multiplied by -1 gives me -0.1, and so on. 1/10 multiplied by this is -0.2. 1/10 multiplied by 4 is -0.4. Sorry, positive 0.4. Where did I get -0.4 from? Did I miss something on that? Okay, to check, I actually missed the part where you have to check, but you can check it yourself. What you have to do is multiply this by this and see if you get a unit matrix. So if you multiply this by this, you should be able to get a unit matrix. Okay, I'll leave that for you to do. You can check. Okay, next question, next example. Find the values of x and y given this information. Okay, this is now based on equal matrices. So using the method that you learned to multiply, 2 times x plus 1 times 5 here. And this one will be 3 times x plus 4 times 5, 20. Okay, this one is 4 times y. Sorry, where am I? Okay, that's 4 times 5 is 20. 2 times 2 is 4. And then 1 times y is y. 4, where is it? 3 times 2 is 6. And 4 times y is 4y. And that's equal to 7, 10, 23, 30. And then if you're using the idea on the equality of matrices, then you say 2x plus 5 is equal to 7. You can also use 4 plus y is equal to 10. 3x plus 2y equals 23, and 6 plus 4y is equal to 30. Okay, is that clear? Now, if you use this 2x plus 5 equals 7, then 2x equals 2 and x is equal to 1. We could have used 3x plus 20 equals 23. If 2x plus 20 is equal to 23, and then you will get 3x is equal to 3 and x will be equal to 1. You still get the same x value. And then for the other side, 4 plus y is equal to 10. Then y is equal to 6. You can also use 6 plus 4y equals 30. If you subtract 6 on both sides, you will get 24. Divide 24 by 4, you still get 6. Okay, so that's based on the equality of matrices. Now we come to solving simultaneous equations using matrices. Okay, so consider the simultaneous equations 3x plus 2y equals 12. And 4x plus 5y equals 23. Okay, if 3x plus 2y equals 12 and 4x plus 5y equals 23, we can rewrite this in matrix form using the coefficients of x and y. So in the first set, we just use the coefficients. So 3 and 2, they are the coefficients of the first equation. So 3 and 2, so long as you take note of that. 3 and 2, 4 and 5 equals 12, 23. Sorry, forgot to multiply by x and y. Okay, if you multiply, just to go back to this, you will get 3x plus 2y, remember how we multiply, equals to 12. Okay, and 4y plus 5y will be equal to 23. Oh, sorry, 4x plus 5y is equal to 23. Okay, what we do is we use the idea of the inverse. Okay, so what we do is we let a equal to 3, 2, 4, 5, and x equal to xy. There are 3 matrices here. There's 1, 2, and 3. Okay, and k is equal to 12 or 23. And then We multiply. A times x is equal to k. Is that okay? Because this is A, we make this one A, this one x, and this is k. So they're supposed to be equal if you multiply. So A times x is equal to k. And if we divide A on both sides, we get x. Now dividing by A is the same as multiplying by the reciprocal of A. So A to the power of -1 multiplied by k will be equal to x. Is that clear to everybody? Wui and Taumaku, stop sleeping. Okay, so A to the power of -1, the reciprocal of A, you multiply 1 over the determinant, which is 3 times 5 minus 2 times 4, clear? Multiplied by 5 minus 2 minus 4 and 3. Okay, you'll have to get this right because that's what you follow when you solve simultaneous equations using matrices. All right, the next line, A to the power of -1. Now, how did I get 5 on 7 minus 2 on 7 minus 5, 4 on 7, 3 on 7? Multiplied what? Okay, that's 15 minus 8 is 7, so 1 on 7, all right. That's how I got A to the power of -1, because I missed one line. I didn't put one line before I got to this. And so x, that x on y should be x. Is that x supposed to be x on y or xy? Okay, it's supposed to be xy, not x on y. Okay, that line is supposed to be x y equals 5 on 7 minus 2 on 7 minus 4 on 7. What's the other one? 3 on 7. Good. You are all awake. Multiplied by 12. 1223. Now, if I multiply 5 on 7 multiplied by 12, I get 60 on 7. Then I multiply minus 4 on 7 by 12. And I add. Is that correct? Huh? Minus, do I multiply minus 2 on 7 by what? 23, or do I multiply minus 4 on 7 by 12? Huh? Minus 2 on 7 by 23. Do I put it here or here? On the right or at the bottom? On the right. Okay, minus 24 on 7. Then, okay, plus, yeah. Should be plus minus 24 on 7, yeah. And then, minus 4 on 7 multiplied by 12. So, minus 48 on 7 plus 46 on, is it 46? 6. Ah? Sorry, they're supposed to be negative. Okay, 60 on 7, that's this times this, and then minus 2 on 7 times 12. Oh, this multiplied by this. Negative 46, and this one by this And then 3 on 7 by, okay, 69. Okay, 60 on 7 minus 46 on 7. 14 on 7, 2. Minus 48 on 7 plus 69 on 7. 3. That's 21 on 7, which is 3. Okay, so xy is equal to 2, 3, which means x is equal to 2 and y is equal to 3. Can we check if we are correct? 3 times 2 is 6. 2 times 3 is 6. 6 plus 6 is 12. 4 times 2 is 8. 5 times 3 is 15. 15 plus 8 is 23. Okay. Question number 1. Find the values of L and M in the following matrix addition. You are given the answer. You have to find L and M. Quick. You have 5 minutes for that. You don't have a textbook, huh? Oh, okay. This afternoon, come and check. I'll do the worksheet for you. It's how many? 1, 2, 3, 4. You never came and picked up your exercise book. Do you have an exercise textbook at the back? These ones too, they have no textbook. Can one of you girls give them one of your textbooks first, just to use for this lesson? Okay, I'll do the worksheet first for those students who don't have, and I'll give you. Come and pick it up this afternoon, your textbook. I'll just do the worksheet next lesson. You want the next question? It's number 2 on exercise 30.1. Yeah. I sometimes get mixed up. Is the bell gone? Is the bell gone? Yeah. You finished 3 already, yeah, and then number 4. Do number. Those are the only 4 I put down on the exercise. Is it 18 or 14? 12. 4 times 12. 16 plus 12 is 20. Please quote it is 14 and 26. 4 times 4, and then 3 times 4. And then 4 times. Check the numbers if that's one. Finished? 1, 2, and 3? No, not yet. Okay. The answer for question 1. Peter, can you give us the answer for 1? What's the value for L? And what's the value for M? Pastor Mike.
L equals 3 and M equals -1.
Right, L is 3, M equals -1. All agree? Yes. Number 2, you have to square A. Kila.
First column is 26, 14. Next one, 35, 19.
Okay, 26, 14, 35, 19. Okay, good. You're going to complete question 3 because most of you haven't completed question 3 yet. You'll complete question 3 and question 4 for homework. They are the same questions 3 and 4 from your textbook. Okay, and then the rest of the exercise we will look at in the next lesson. The keyword for or to the pilot teacher is solve simultaneous equations. Okay, can you please stand? Good afternoon, class. Thank you.